Okay, so I repeat it again. If I have one force in the upward direction, okay, and one force is in the horizontal direction, okay, these are two different forces, F1 and F2. Okay, then the resultant force direction is represented by joining first vectors A and second vectors N, like this. Like this. Okay. So this will be the resultant vector, that is R vector. Okay. So now you need to see that. This is resultant vector. How is it came from? Like how did it came from? First of all, I want to inform you that if I say this is the kind of vector, then this is called ad hoc vector. Okay, and this is called tail of vector. Okay, tail of vector. So if you want to add two vectors like this F1 force and this is F2 force, then the net force will be in this direction. Okay, here you need to see this. Both the forces are in 90 degrees. You understand that? See, both forces are perpendicular. So this is compulsory that there should be what? Perpendicular to each other. If these four forces are perpendicular to each other, so this will be what? Resultant. Okay. So now, if I say that, what is resultant force? So resultant force is basically sum of these two forces. F1 force plus F2 force. Okay, this should be what? Resultant of these two forces. Okay, F1 plus F2. Huh? Pythagoras theorem. Yes. But Pythagoras theorems will be using for evaluating magnitude of this object. Okay. We will use Pythagoras theorem again for evaluating the resultant vector of this R vector. You understand that? Okay. So right now, this is what R vector is not the same as Pythagoras. It's simply R vector is equal to F1 vector. Simple. So it is like this. If one car is going in this direction, okay, and other object is going in this direction, and it hits like this, okay, then what happens? Then the force between these two vectors, these two cars will be acting in this direction. Okay, so both cars will be going like this. Okay, it will resultant, it will go in this direction. You understand that? Okay. So now if I want to evaluate the resultant magnitude, R vectors magnitude, so it will be like what? If I say this is point A, this is point B, and this is point C, then I will say that AC square must be equals to BA square plus BC square. By what? By Pythagoras. Okay. So in that case, AC must be equals to root of BA square plus BC square. Is it? Okay. Now what you need to understand? What you need to understand here? That if AC has value x, then what is BA? BA is what? A to B, it is what? F2 vector. And what is F2? F2 vector is magnitude is what? See, you all know that. How do we represent any vector? If there is a vector, that is A vector. It is what? A vector's magnitude and A vector's direction. This is what? Direction. This is what? Magnitude. You understand that? Okay. Direction and magnitude gives you what? And if you want to evaluate this magnitude only, how can you evaluate the magnitude? So magnitude is what? Length from here to here. So if I say what is F vector? So F vector has what? One is magnitude, and the second is what? F vector's direction. Okay. So if I want to evaluate F2 vector's magnitude, so what will be the magnitude? So I'll say that BA vector's magnitude is what? F2. That is magnitude of F2. Okay. And BA, BA of B minus? Where is B minus? This one. This one. Huh? This one is vector. BA, sorry, AB vector is actual vector. AB, not B. Okay. A to B. B to C. So it should be AB square, not B. Okay. So to avoid your confusion, okay. So A, B vector. So from A to B, it is AB vector like F2. Okay. So AB vector's magnitude is what? F2. Okay. And similarly, BC vectors magnitude is what? It is F1. So can I put the value here? And AC is what? AC vectors magnitude is what? R vectors. That is what? R vectors magnitude. So if I want to write this, if I want to write like this, so R vectors magnitude will be like this, under root of F1 square plus F2. This is a simple rule to add two vectors and they are copied. You understand that? You can apply this rule, and this rule is basically known as triangle law of two vector addition. Okay, this is known as what? This is known as what? Triangle law. Triangle law of vector addition. This is basically this triangle law of vector addition. You understand that? Okay. So now let's take some questions. Okay. Do you know that? Do you know that how we represent other forms of vectors? Like if I say there is R vector, it can be like this: 5 I cap plus 3 j cap plus 2 k cap. Have you seen like this? You never seen like this? Okay, relax. I won't discuss it. I will never discuss this. Okay. Now, first of all, if this is F1 and this is F2, you know that this is kind of a force, and if I say this is F1 vector, and it is 50 Newton. 50 Newton. In direction of what? Direction is what? Direction is east. Like I say, 50 Newton is not moving north, south to north. So north is the direction, is up, right? And F2 vector, let's say this is 20 Newton, or I say like, yeah, 20 Newton, it is. Okay, and it is what, east. Then I want to know that what will be the resultant vector. So it will be what? Northeast? Is it east? Is it west? So it is west. It should be west. Right. So if I say this is west, then what is the direction of resultant vector? Northwest. Okay. So resultant vector, this is fixed. This is fixed. It will be like northwest. Okay. Now I want to evaluate the magnitude. So what is the magnitude? So magnitude. Please evaluate the magnitude as a resultant vector like this. So 50 square plus 20 square. So it becomes what? 2500 plus 400, isn't it? Okay, so it becomes what, like under root of 2900? Okay, what is the value of root 2900? Huh? 53.85. So the net force will be in this direction and it will be like 53.8 Newton. You understand that? So the resultant force will be in the northwest direction and its magnitude will be like 50. This is the kind of example I am giving. Okay? Okay, let's move ahead and let's take some questions. Okay? On perpendicular. Okay? Okay, let's take some questions. Are you noting it down? Please note it. This is important for okay? And this is also important. And this is R vector is called resultant vector. Okay? Resultant is called addition of huh? Net force. That is addition of two vectors. So basically we have added F1 vector. Okay, can you have this? Now, let's move ahead. Let me give you a good question. Okay, let's start discussing some questions. So let me write here, like f vectors, like resultant vectors magnitude is equals to under root of f1 square plus f2 square. Okay, now let me give you a question. Okay, a man is pushing a car in some direction by 30 Newton force. Okay, 30 Newton force. Okay, a car traveling west to east hit the car, hit the car by 20 Newton force. Okay, what will be net force on car and its direction? So you can also draw a scale diagram. Huh? You can also draw a scale diagram. Yeah, definitely. So this is a car, it is going like downward, right? Yeah, definitely. So it is going like downward, 30 Newton force, okay? And a car which is coming from this direction, like this. Okay, so now if this car is pushed like this in this direction, but going like this south to southern direction, right? So if it is pushed like this, its resultant force will be like this direction. You remember, you need to remember, you need to try what? Tail of first vector with head of second vector. You need to make sure that you join what? Tail of first vector with the head of second vector. So it will be what? Resultant force. This force is 20 Newton. So this force is what? 30 Newton plus 20. Understand that? Okay. So what will its magnitude? So magnitude will be, since it is a 90-degree angle, by the Pythagoras, I can tell that it will be 13 square plus 20 square. Well, can you see this? Isn't it? Okay. So 13 square is 169. Isn't it 169? And 20 square is what? 400, right? So it will be like 569, right? So under root 569 we need to calculate. So under root 569 is what? 23.8 Newton. Huh? And sound vector. Is it easy? No problem? Okay, and the direction will be what? South. So, sorry, southwest. So what was the rule again? The rule. It is triangle law of vector addition. No. Yes. See, it is, you have to watch tail of first vector to connect the head of second. Okay, we connected what? Tail of first vector to head of second vector. It gives you resultant vector. Okay, so if you want, I can write it. Should I write it? No, sorry, I got it. So resultant vector is can be attained by joining first vector space to head of second. You can write like this. Okay, now let's take some special case. Special case. Okay, can I do this? Okay, let's take some special case. What is special case? You have noticed that here, both forces are perpendicular. This is clear. But what are we saying? These forces are not co-initial. Co-initial means what? Co-initial means what? Two forces which are acting on the same point, or the point of application is common. Those are called what? Co-initial vectors. Okay. So basically, if I say this is the block, a block. Okay. Let's say this is a block. A force is acting in this direction and also in this direction. See, two forces there are F1 and F2. They're both perpendicular, right? Okay, but they are not like this. Are they like this? Well, yes. Can you see this? There is a block given here. Okay, it is a metal block, wooden block, whatever you can call it. Okay, there is a one force acting upwards and one force acting in the east direction. Okay, here, can you find the difference? Here, these forces were like this. One force is acting like this, and the second force acting like upward. So the tail is joining with the head of the other one. Okay, here. But here both are starting from the same point. So here the tail is joining. Yes. So what will be the resultant? So in order to find the resultant, like you have two vectors, like I write like this, special case. Special case. What is special case? Addition of two perpendicular co-initial vector. Co-initial vector. Okay. So in this case, you'll see that one force, I told you that if it is upward direction, and second force is in this direction, then how can you add them? See, I can say this. This is the 90. This is F1, this is F2. Okay. In this case, you have to use what? Convenience of vector. Since force is vector quantity. And in vector quantity, you can do what? You can shift any vector from one place to another place, provided that you do not change its direction and its length. So see, this vector can be made here also, provided you just make it the same size and the direction remains the same, like up. Okay, so this is F1 vector upward, this is also F1 vector upward. You understand that? Okay. So this is F1 vector, this is F2 vector. And I can see this, I can say this. This is also F1 vector. Okay. Because the magnitude is same for both of them. If this is F1 vector, this is also okay. Because the magnitude is same, the direction is also same. Okay, now you can see this. It's tail and its head. You need to join this only. So if you join these two, you get what? Resultant. You understand that? Okay, here, you can see this. This is the resultant vector. Okay, now the same case applies. F2 plus F becomes the same. Tell me, now it becomes the same? Same case. So in case of co-initial perpendicular vectors, or in case of co-initial perpendicular forces, you need to add them. Okay. So the resultant will be always. Now, if I say this, a swimmer applies 10 Newton force in water. Okay, and river applies river applies river applies let's say it is 5 Newton force on any object in okay. A swimmer applies 10 Newton force in water, and river applies 5 Newton force on any object. Whatever object that is in river, rivers they apply what 5 Newton force. Okay, and if swimmer jumps into the river, that river will also apply what 5 Newton force on it. Okay. Now, if swimmer mass is if swimmer mass is let's say 45 kg, then with how much acceleration he will swim in water, in river. Okay, if its mass is given, now you are going to ask about acceleration. What is it like acceleration? Okay, with what acceleration? How much acceleration you swim in what river? Okay, river river flows from what? River flows from east to west. Okay, and swimmer wants to cross it. Swimmer wants to cross it. So, any method you can take. If he's crossing it, either he will go north to south or south to north. Such data you need to evacuate from the question. Zero point two four eight acceleration. And in which direction acceleration? Tell me both conditions. If it cross for north to south, and if it yes. Make the diagram. Don't think like this. Make the diagram. Make the diagram. For both the condition. Okay. Number one condition you will take from north to south, and number second condition you will take south to north. Mm. It will be 0.4 southwest. Mm. And if it's going from south to north, it will be impressive. Now, what about you? Zulfikar, it's not a teaching class. He what? He came today or not? And what about that other student? Yeah, same. Huh? Okay, but he was not online. Okay. Okay. So doesn't the does the diagram change when yes, two conditions you can go. Okay. First condition is for north to south, and second condition is south to north. Value will be the same. Yeah. Definitely. The river will apply 5 force constantly. Okay. So the answer for acceleration is 0.5. How much you want? 2.8. That is 2.5. Yes. Okay, so you will do like this. If the river is going from east to west, right? So it is going like this in this direction. Okay, and the swimmer is actually, let's say if it is going from like, I'm making a very clean diagram, right? If the river is going in this direction, you take two conditions. Okay, if it is going from north to south, it will be going like this, and if it is going to south to north, it will be going like this. Okay, in both the cases, you know that resultant force will be like this, and in this case, resultant force will be like this. You know that. Okay, so here, if this is what, this is north, this is east, this is west, this is south. And you can say this is what, west south direction or southwest. You can say this southwest. Okay, this will be what, northwest. Now the things remains about what, acceleration. Okay, the acceleration value will be seen like what, under root of a resultant vector magnitude we are already is what, 5 squared plus 10 squared. So resultant vector's magnitude will be what, 25 plus 100. That is what, under root 125. This is what, resultant force, isn't it? So resultant force magnitude is what? How much it is? 11.18. Okay. Now this is what resultant force. Now you will ask like acceleration, but force. So you know that force is what? Force is what? Mass times acceleration. So acceleration is what? Force divided by mass. You get the force? What is the value of force? 11.18 divided by what is mass? That is 45, and you will got its acceleration. It is easy. So this is these kind of questions you will ask. Okay, this is actually previous some question. This is I picked up. Okay, and such questions are more of and if they ask that what is the direction of acceleration, the direction of acceleration will be the same as direction of force. Right? See, force and acceleration both share the same direction. Okay? The direction will be the same. So it doesn't mean you go northwest, but you go southwest. With acceleration over how much acceleration you can meter per second. Is this okay? Should we move ahead? Should we take some advanced problem? Now let's take some advanced problems. Now, what happens? Come back fast, okay? I'm waiting for you. If you want to go, you can go. Do you have any suggestions like what should we do some exception? Like after this or any kind of class? Like are we going to like specifications and other things are not in school? Like what? Unit 3 practicals. They are teaching in the school unit 3 practicals. Sorry? Every week. Okay. So you do one practical in the school. Right now, what I'm asking is, in the school, are they teaching some different things or the same things? Sorry? dynamic equations that we did in the last class. Okay, those equations we are facing. So the velocity acceleration now is completed. This moments. Okay, the force is also completed. This also completed. Okay. So did they taught something different or the same thing written? Same thing. So any suggestion from your side? What should I add? If you want to add. Okay, movements. Anyway, we are going fast. Okay, we'll complete this topic today. In the next class, we'll start movements. Okay, don't worry. Don't worry about it. We'll back up very fast. Okay, you understand that? Can I move ahead? Now, the second case, let us take in the case of if we take like the both forces are not compelling to each other. You understand that? Right now, if we case if the forces are not compelling. Okay, so second case. So this was the case just for what? The forces should be what? Perpendicular, purely perpendicular. Right now, the case is changing. They are not perpendicular. They are at any general limit. Okay, so then how we will act? That's okay. Okay, so now second thing that we are going to discuss here, right? Two forces acting at certain angle. Okay, two forces acting at certain angle. Okay, certain angle or general angle. Okay, or any angle. So two cases again rises. What cases? See, one case in which we will discuss, in a single case I will discuss anything, everything. Okay. So if I say this is the force, force F1, and this is the second force, that is force F2. Okay, this is the first force in this direction, and this is the second force that is F2. Okay, and they are both at certain angle. Let's say it is theta. Okay, theta is the angle between these two F1 and F2. Right now, I have been asked that what will be the resultant force. See, this is not perpendicular right now. So how we will evaluate the magnitude of the resultant force and what will be the resultant force? These things we need to evaluate. Two things only. Number one, what? Resultant force. Number two, what? Resultant force magnitude. These two things will be asked. Okay. So let's make it more and more bigger. Okay. So this is again F1 vector, and this is again F2 vector. Okay. Now, if I say this is what, this is A, this is B, okay, and this is C, right? And the angle between them is what? Theta. Here, what I need to say, I told you earlier that if we have this vector can be moved from this position to this position, provided that we do not change its magnitude and its direction. Okay. So if I take the same direction like this, yes, so it will be what? Parallel. Okay, so basically, if I say this vector is F1 vector, this is the same direction, so this will be what? Again, F1 vector. And if this is F2 vector, this will be what? So again, it will what? Parallelogram. Okay. Basically, it is what? The same triangle law. Okay. The same as triangle law. No difference. The same as triangle law, but some feature has changed. Okay. Now it is what? Initial, it is final, and now it is add and tail are joining here. So we can start from this point and go to this. So the resultant force will be like this. Again, I will join from this point to this point. So this will be what? Resultant. You understand that? Now this is resultant force. Okay. So this is resultant force. Can I evaluate the resultant force value? It is simple. Resultant vector is what F1 vector plus F2 vector plus. Okay, but the main problem is that there is an angle which can. Okay, so simply I can say this R vector is what F1 vector plus F2 vector. That is. But what do you need to see? What do you need to see? If I want to evaluate the magnitude, that is A and C. A, B, C, and let's say this is D. This is D. Okay, then I want to know that what will be the magnitude of E. Okay, huh? Scale diagram. See, right now I need to make some certain sort of constructions in this plan. Okay. What constructions? Okay. Let me tell you. I will extend the speed from this point to some other point. I extended this speed. Okay. This B point is extended somewhere. Okay. Now from B point I will do this perpendicular is N. Okay. And if this is a perpendicular, you can see this. If this is a line which is going like this is two lines which are parallel, right? Okay. If these two lines are parallel, this is transversal line, and this is the angle theta with this, then this angle should also be what? Isn't it? Okay. See, these two lines are parallel, and this is transversal. Okay. If this is theta, it should be also. Okay. Now what I want to evaluate? I want to evaluate this magnitude. So you can see this. You can see this triangle. Initially, if it would be perpendicular, this is very simple. Perpendicular would be like R vectors is equals to whatever of F1 square plus F2 square, but it is not perpendicular. So we need to evaluate the magnitude. That's a further value. Okay. So we extended Pn and En construction degree. Okay. Now, yes, in triangle B and D. Can you see triangle B and D? Please tell me in triangle B and D, what will be the value of Bn? If you have given the angle theta, and if you have given the hypotenuse, this is perpendicular. If this is perpendicular, this is hypotenuse. Well, this is perpendicular, this is base, and this is hypotenuse. Okay. You tell me that. What is this? F2 vector's magnitude is what? F2? From here to here it is F2, right? So I can say this. If I want to evaluate base and I have given hypotenuse, which trigonometric ratio I will use? Cosine. Cosine, definitely. Because cosine has base and hypotenuse. So I'll write like this: cos theta is equals to what? Base over hypotenuse. Base is what here. What is hypotenuse D? Okay, so cos theta is equals to what is Bn? Bn we want to evaluate. And what is BD? BD is what? F2. Now tell me. What is the value of Bn? So here I will say that Bn is equals to F2 cos theta. Is this clear? So is it done before or is I'm doing it first time? Is it done before? Not done? Okay. So I'm actually evaluating this method. Okay, relax. It is very useful for you. You just remember one formula, you can any kind of question with any angle. Okay? Relax. It is not a bad thing. Okay, it is very useful for us. We can evaluate magnitude of any two forces which are at any angle. Okay? Well, are you interested in this? Okay. Now, please tell me, what is the value of B? If you are given perpendicular and hypotenuse, which trigonometric ratio will be used? Sine, definitely. So, what is the value of sine theta? So, sine theta will be like what? B and over F. Right? F2 is what? This is F2. Oh, sorry, F1 is. It should be F1. No, sorry. Yeah, it is F1. And by mistake, we did like this. Okay. This is F1. F1. Okay, this should be F1. So this is F1 also. So tell me, what is dn? Dn should be what? F1 sine theta. Okay, so here in this diagram, I can clearly see that. I can clearly see that this length is what? F1 sine theta, and this length is what? F1 cos theta. Now, is it okay? Is it okay to hear? Okay. Now we got these two lengths. Okay. Now you see A and B in triangle A and B. In triangle A and D. A and D. This is perpendicular. This is whole hypotenuse. Right? This is perpendicular. This is whole base. Now tell me, if I want to evaluate this hypotenuse, I have base and perpendicular both. Then can I use Pythagoras theorem? So yes, in triangle A and B, Pythagoras theorem. By Pythagoras theorem, I can say this: AB square is equals to an square plus bn square. Please tell me if I'm wrong. Well, is it okay? AB square is equals to an square plus bn square. Here. Basically, simple Pythagoras theorem. Okay. Now, what is AD? AD is what? Magnitude of R vector, resultant vectors magnitude. Okay. So I write like this: resultant vectors magnitude, that is R square. Okay, is equals to an. An is made of two lengths, AB plus BN. So I write like this: AB plus BN square plus BN square, isn't it? Can you see this? The whole AN is made of two things, AB plus BN. See, this is from A to N, right? AN is made of two lengths, A to B, that is F2, plus B to N, that is F1. So when I add up both of them, you understand that? Okay. Now R square, that is relative vector magnitude R square is equal to is how much? Is how much? That is AB square plus BN square plus 2 AB multiplied by BN plus BN square. I expanded this. It is A square plus B square plus 2AB. Is it okay to have? No, please stop it. I think you okay, just stop. Okay, just watch it first. Okay. So if I have done this, now tell me what is AB? AB is what actually? See, I'm writing like this. AB is equals to F2. AB vectors magnitude I'm talking about. Okay. The length from here to here is what F2. Now from length here to here is what BN. BN is what in their radian after cos and A, B, and BN. AB, AB, BN, also the side. Right. So right now I'm putting some values here. Right. I will put some values. So now R square will be like what? AB is what? F2 square. F2 square from A to B, length from here to here will be F2. So this F2 square plus Bn. Bn is what? F1 square cos square theta. So are you getting easy? Or like, and is it boring? No boring? So now Bn is what? F1 cos F1 square cos square theta because we squared it. Both sides squared. Right? Now 2AB plus 2AB. AB is what? AB. This is F2. What is BN? BN is what? F1 cos theta. Now what is dn plus? What is dn? dn is what? f1 squared sine squared theta. Now carefully watch this. f1 squared cos squared theta, f1 squared sin squared theta. Can I take common f1 squared both of them? f1 squared can be taken common, right? So here r squared is equals to f2 squared plus f1 squared I took common, it became sine squared theta plus cos squared theta. Okay, and this gives me 2 f1 f2 cos theta. Now please tell me, what is sine squared theta plus cos squared theta? It is 1 sine squared theta plus cos squared theta. Is it 1 or not? You don't know? Okay, let me tell you. What is sine theta? It is what perpendicular over base. Right? Please see. It is what perpendicular over hypotenuse. And what is cos? It is base over hypotenuse. And I'm squaring and adding both of them. I'm squaring and adding both of them. Then what will happen? It will happen like this. b square over x square plus b square over x square. I'm doing this. I'm adding like this. So what happens? H square can be taken LCM. So LCM is what? H square and upper will be what? B square plus B square. This is what? Perpendicular square plus base square. What is perpendicular square plus base square is equal to? Hypotenuse square. So it is hypotenuse square. Hypotenuse square cancel out equilibrium square. Well, how is it? It's okay. It's really right. So again, it's so obvious. Huh? It's a lot of detail. Yes. So here it becomes 1. This whole term becomes 1. Right? If it is 1, I can write like this. Resultant vectors is equal to f2 square plus f1 square. This 1 multiplied by f1 square is f2, right? Plus 2 f1 f2. This one is r. So r is equal to under root of f1 square plus f2 square plus 2 f1 f2. You understood that? Here, theta is the angle between these two vectors. Okay? And f1 and f2 square. See, this is for what? Two forces acting at a certain angle. That was specifically acting at one perpendicular. Initially, we did for what? Perpendicular. Now it is at an angle. Like this angle also. Theta. Now, I can square that into very easily. If I say this, these two forces having perpendicular 90 degree angle. Okay, one force is 10 Newton, one force is let's say this is 8 Newton. Okay, now please tell me, if 90 degree angle, please put theta is 90 degree. Please put what? Theta is 90 degree. And put 10 Newton as F1, please put 8 Newton as F2. What are you get? Sure, okay. And now use this formula as for the both of them. This formula should be used. Now use this formula. What do you get? So this formula is for everything. This formula is for what? Everything. You can use this formula everywhere. The two forces are. If one force is in this direction, that is 30 Newton, and one force in this direction is 20 Newton. Now tell me, if there is angle between 180 degree, what will be the net force, and in which direction it will be? In this direction? Okay. So is it become easy? Now, please use the formula. This one. And tell me what the value is. Is it 10 or something else? That's it. So this formula, this machine, everything. Get it what I said. So this is the formula for like what? Like two vectors and a certain angle. You can achieve anything by putting certain angle value here. F1, F2, and you can achieve anything. Is this okay? Have I taught too much? Is it useful? So in your book, basically it is given like 50%, like nothing is discussed like this. It is given like this only. They haven't discussed anything like this only. I know that this is extra, but still it is useful. Alright? Any angle you find, any angle you given, you find the value also. These things we study in IIT and all. This is somewhat like complicated, but still it is useful. Yeah, it's been 6 months here. Yeah, I was just I have a lot of information, a lot of things I know, but I fear to express it to you because you will say that sir, this is not involved in specifications. So I fear it. Otherwise, I have a lot of things to tell you. But anyway, you don't know that sine squared theta plus cos squared by 1. Okay? Have you done trigonometry? Like, uh, can you show me that? What is your like level of trigonometry? Like, can you show me your book? Next book? Oh, okay. You're not taking maths. Okay, what about your math? Okay, so it's useful for you. You should know that science for example is cost principle one, isn't it? Huh? Okay, that's good. So anyway, so still it is useful. Okay, don't fear it. Okay, it's simple. If you don't want to learn it, it is still okay. But this formula is very useful. This is like three. Any question you can touch on. Very easy. Now let's take some questions. Good questions. Still 15 minutes. Let's take some good questions. So which level you select the subjects? Okay, 11. You have study mathematics in 11. Till year 11, you study all subjects, but after year 11, in the year 12, 3 to 4 subjects you have to choose. What 4 subjects you choose? Huh? Triple, triple science. Okay, biology, chemistry, and physics. That's good. on these 6 subjects or 4 subjects here? Arabic lessons. Is it good? Okay. Should we move ahead? Take some good questions. Okay.
So you show them how science were
Yeah, I can show you. This is simple. This is very simple. Let me show you. Should I remove this? Now, please tell me. Let's take this triangle A, B, A, B, N. Okay. In this triangle, I will show you. It is always sine squared plus cos squared is equal to 1. How does it? A and D. In triangle A and B, you please tell me what is AD squared is equal to AN squared plus BN squared? See, this is Pythagoras theorem, right? AB squared is equal to AN squared plus BN squared. Okay. Now, please tell me if there is angle, if there is angle between the hypotenuse, this is space, and this is alpha. Okay, then now tell me in A and B, what is sine alpha?
it should be
Perpendicular or hypotenuse. What is perpendicular? Oh, wait. It should be dn over this hypotenuse. See, this is nd or dn, whatever you say. Dn perpendicular or hypotenuse. It should be. Tell me, this is perpendicular or hypotenuse. Right? Now, tell me what is cos alpha? Base over hypotenuse. What is base? A and D. Now tell me, when you square it, if you square both sides, it becomes sine squared alpha is equals to bn squared over a squared, isn't it? And here, if you square both of the sides, it becomes cos squared alpha is equals to an squared over a squared, isn't it? Okay, now add both of them. So if you add both of them, it becomes sine squared alpha plus cos squared alpha is equals to, you will add both of them also. So dn square over ad square plus an square over ad square. Now take LCM. If we add both of them, it becomes what? an square plus dn square over ad square. Now tell me, what is an square plus dn square? So it's equal to ad square. So it should be ad square divided by ad square. It gets cancelled. What? You got it? So here, is it rocket science? Very simple it is. Now you can solve any question by that formula. Whatever kind of question you are studying, that question is small in different. Yeah? Should I remove this? Okay, let's take some questions. Good questions. Okay. Now, see, mathematics is not a big task. Physics is a big task. Okay? So we have to do physics, okay? Not get involved in mathematics. Okay? So, first of all, here is a question here. Okay? Okay, a kid is pulling a toy car. Kid, see, kid is pulling a what? Toy car. Okay, toy car horizontally. The car is tied with string. Car is tied with string. Okay. Now, if if angle between string and horizon, if angle between string and horizon is 30 degree. Okay, so let's say 60 degree. Yes, 60 degree. And kid, sorry, and car has two forces, two forces, 20 Newton and 10 Newton, 20 Newton and 10 Newton acting, acting, 20 Newton and 10 Newton acting through string and horizontally, respectively. What is net force? What is net force on toy car? See, the good situation I'm telling you. See. Here, this is a ball, okay? Let's say this is a ball. Okay? This is a ball. And there is a toy car. Actually, make a more big diagram. This is a boy. Okay? And he has a toy car. Okay? This is right. There's a toy car here. Toy car is very bad. Still is right. Okay? So here the toy car is changing, like the style is changing, right? Now, one force that is 20 Newton in the string, through the string, right? 20 Newton in this string. This is 20 Newton. And one force that is also acting between this is called a frictional force, right? Frictional force between the toy car and the horizon. Okay. This force is in this direction. It is what 10 Newton, and this angle between them is what 60 degree. What is the net force? That's interesting. So how did you find it? Simply do what 20 square plus 10 square plus 2 multiplied by 20 multiplied by 10 multiplied by what? Cos 60. What about your method? You understand? Yes. It's simple. So the net force will be in this direction, in this direction. If the net force is in this direction, the car will move in this direction. Isn't it? So tell me this equation reminds me of Same thing, this is true. Yeah, this is question good, yes. You will do that. Yes, yes. But tell me then, where the symbol matches in mathematics, right? So it is negative, it is plus. Okay. Okay, so here, but your memory is good. And I can say, because you find it like this. Okay, so this equation will be answered. Okay, so it should be what? 400 plus 100 plus 220, 40 plus 400 multiplied by cos 60 is what? 1 by 2. So cos 60 is 1 by 2. 1 by 2. So 1 by 2, so 2 into this gets cancelled, this is 200, right? So 400, 200 and 100. How much is it? Like 400, 200, 600, 700. 100 700. What is the value of 100 26 points? Newton. In this direction. How is it easy? See, this is a complex problem. If you don't know that formula, it is complex. But if you know the formula, it will be very easy. This is how the formulas are used. So, how is it well? Huh? Yes, it was good. It was good. Yes. Huh? Like what? What I said? Yes. If such questions comes in front of you, it will be 5 minutes. Definitely you will get this. You can do this. But I don't think so. IGCC will ask such questions. You understand that? Huh? So at Excel, they ask such questions. Okay, I'll check that tomorrow. Okay. When will you have second class tomorrow? Thursday. On the Thursday, when you come, I'll collect some previous year questions of the courses, addition of courses. Okay, and I will make sure that I'll get good questions. Okay, and then I will know, we will know that what kind of question you ask. Okay, okay, ma'am. Okay, Zohaib. Okay, thank you so much. Thank you. Sorry? No, there's no one on the online. I just recorded it because students were saying that if you can record it, so I said that I will record.